In this lesson, we're going to talk about secant lines and tangent lines and their slopes. We'll start with a picture. All right, here's a picture of a secant line. The secant line crosses a curve at least twice, and when it crosses, it does just that. It crosses from one side of the curve to the other side of the curve. And here's a picture of a tangent line. Now, a tangent line touches a curve at least one point, and at the point where it touches the curve, it doesn't cross from one side to the other. So if you look within this circle, this piece of the line stays on only one side of the curve. Okay, just look at those two pictures together and you see the difference. The secant line crosses over from one side to the other, and the tangent line stays on one side. All right, now we want to look at the slope of a secant line. Well, the slope of a secant line is going to be the same formula that we use for the slope of a line. After all, it is a line. Let's just recall the formula for the slope of a line. So we subtract y's in the numerator and subtract x's in the denominator. So here, this point would be point x1, y1. And this point we would label x2, y2. Now we're going to rewrite this slope formula. We're just going to label our points differently. All right, here we have the secant line again. This line is the x-axis. So on the x-axis, the x-coordinate of the first point we're going to call C, and the x-coordinate of the second point we're going to call x. Using function notation, assuming that this is the function y equal f of x, this first point we'll label C for the x-coordinate and f of c for the y-coordinate. And this second point we're going to label x for the x-coordinate and f of x for the y-coordinate. And now let's rewrite our slope formula. Change of y is on top, and change in x on the bottom. We're going to do this one more time to get another form for the formula of the slope of a secant line. Okay, we'll label our first point x on the x-axis, and the second x-coordinate we'll call x plus h. So that means this jump, or this gap over here, would be h. All right, now let's label our points. So our first point is x comma f of x. And our second point is x plus h comma f of x plus h. Now let's rewrite our slope formula. Change in y's. Over change in x. Notice this denominator simplifies. X we have here and the minus x, those just cancel. So this formula becomes f of x plus h minus f of x over h. This is a familiar object. This is what we call the difference quotient. And in section 1.5, we were simplifying these difference quotients for various functions. So here we have our two formulas for the slope of a secant line. All right, one formula comes from labeling our 2 points using c and x for the x-coordinates, and in the other formula we label the x-coordinates as x and x plus h. In number 1, we want to find the slope of the secant line through y equal x squared from x equal 1 to x equal 2. All right, so if we write f of x is equal to x squared, when x equal 1, f of 1 is 1 squared. And when x equal 2, f of 2 is 2 squared, or 4. So our 2 points on the line would be 1, 1, and the second point, x equal 2, y equal 4. And for the slope, we're going to subtract the y-coordinates, 4 minus 1, and subtract the x-coordinates, 2 minus 1. So in the numerator we have 3, denominator 1, so the slope of the secant line is 3. Okay, in number 2, we want to find the slope of a secant line, again through y equal x squared, but this time from x equal 1 to x equal 1.1. So here I have two graphs of y equal x squared, and in the first graph we're picturing the secant line from x equal 1 to x equal 2. In number 1 we found that this blue line over here, that was the secant line. Okay, and it goes through points 1, 1 and 2, 4, and we found that it has slope 3. All right, here's our secant line from x equal 1 to x equal 1.1, and here we have a picture of that secant line, and we want to see what the slope of this secant line is. It looks like it's not as steep. It looks like the slope will be smaller than the slope of this line. All right, in fact, just from looking at the picture, we can approximate it if this is an accurate picture. All right, let's look at this little line over here. We have it drawn on the grid, so it looks like it's heading towards this cross point here. And if we were to just count boxes to get from this point to, let's say, this point, it looks like we go up 2 and right 1 approximately. So it looks like the slope should be approximately 2. All right, here you see we go up 3 and right 1, so the slope is 3, and here up 2 and right 1, approximately 2, because this isn't necessarily going to cross the intersection, right over here. It'll be close, but it won't actually cross it. So the slope here is approximately 2. All right, so from the picture, that's what we see. So let's do a little calculation and see what we get. Okay, so our first point has x-coordinate 1, and y-coordinate, we're just going to substitute into x squared, y-coordinate 1 squared. And our second point has x-coordinate 1.1, and y-coordinate, again, substituting into y equal x squared, 1.1 squared, that's 1.21. All right, so our first point we could label it as 1, 1. And our second point we could label as 1.1, 1.21. All right, now let's figure out the slope. Subtract the y-coordinates. That would be 1.21 minus 1. And subtract the x-coordinates. That would be 1.1 minus 1. So in the numerator we have 0.21 divided by 0.1. And that simplifies to 2.1. Which is sort of what we expected. We said in the picture it looks like the slope is approximately 2. So we see the slope is close, 2.1. All right, now what we want to learn from this example is that this secant line is actually going to very close to the tangent line through 1, 1. All right, since these points are close together, it is a secant line, but if we draw the tangent line through 1, 1, we will see that it almost coincides with the secant line. All right, so later Suma will be calculating the slope of the tangent line through 1, 1, and we'll see that the slope of the tangent line will be exactly 2. Okay, now we want to calculate the slope of the secant line through y equal 1 over x, from x equal 1 to x equal 11 tenths. 11 tenths is a little bit bigger than 1. It's actually equal to 1.1. So here we have a picture of y equal 1 over x. And these are 2 points. This is the point with x coordinate 1, and this is the point with x coordinate 11 tenths, or 1.1. And we picture the secant line right here. The blue line is the secant line. It looks like it has a negative slope. Just from the picture, let's approximate the slope of this blue line. Well, it looks like it's heading towards this intersection. Not quite, it's going to miss it, but close to this intersection. So that means the slope is approximately, let's see, to get from this point to this, from this intersection to this intersection, we would go down 1, right 1, which would make the slope approximately -1. All right, so now let's do the actual calculation. All right, so our slope is equal to, well, if we label these points, first let's say the first point is x equal 1, and has x coordinate x equal 1, and it has y coordinate 1 over 1, or 1. The second point has x coordinate 11 tenths. F of 11 tenths, that is the reciprocal of 11 tenths, 1 over 11 tenths. Which is 10 over 11. All right, now let's calculate the slope. So in the numerator, we're going to subtract the y's. 10 elevenths minus 1. I'll write this in fraction form, 1 over 1. And in the denominator, we subtract the x's, 11 tenths. Minus 1. So let's subtract the fractions in the numerator and the denominator. We'll get a common denominator here of 11. So in the numerator we have 10 over 11 minus 1, which is the same as 11 over 11. And in the denominator we have 11 over 10, common denominator of 10. So this term will represent 1 as 10 over 10. Subtract the numerator and we get minus 1 over 11. Subtract in the denominator and we get 1 over 10. All right, this fraction simplifies to minus 10 over 11. Minus 10 over 11, that's a little less, slightly less, slightly less than minus 1. If you wanted to look at the decimal representation, this is approximately equal to minus 9.09. So slightly less than minus 1, which is what we expected from this picture. It looked like the slope was approximately minus 1.